start with the very basics, like we generally do. We're going to work our way up through alignment, fine-tuning the whole system. We're not going to cover everything that you did in class. Again, this is just a review. We're going to start on the vehicle with the frame. Anytime that we do work on suspension or alignment, it has to start with the frame. So if the frame is not square, then the whole vehicle is going to be off, right?
Yes.
If we get hit in the corner, if you look at this one, okay, this is a type of ladder frame, which means it's got a frame from side to side and it's got a cross piece. Like this, kind of like a ladder. If one of these vehicles is hit, say it's hit up in this corner, it can actually twist it so the ladder goes like this a little bit. Okay, it's called a diamond frame. If that happens, I want you to look at the axles. What's going to happen to the axles if we're hit in the corner and the frame goes like this?
Dog track.
Axles are going to turn with it, right? And so when we go back to check it, if we check the distance between the center of this one and the center of the rear wheel on both sides are going to be the same, but we have what we call setback because one side is set back further than the other one. So when we do our check, we start with the frame. The frame can be twisted up and down. So you look at the back of the vehicle and just looking at it, maybe one side is an inch higher than the other one in the front or the back. That's going to cause a problem with suspension and with alignment. So we start, when we're looking for a problem, with the frame. We make sure they're going to give us specifications. We're going to make sure that the distance is the same. We find the same spot and measure from here to the ground. Okay? And we're going to see if the frame is twisted up or down like this. Logical? Because if it's not, it's going to affect the way the whole car drives. Agreed? Then we need to find a place back on one side of the frame back here up to the other side, and we're going to do a diagonal check with our tape measure and see if we've shifted back. If it's shifted back, we may measure 67 inches here and 62 inches here. That tells us that the frame is shifted. If that's the case, before you can make that car drive right and fix it, you're going to have to take it to an alignment or a body shop that has a frame machine, because if the very basis of the car is not right, we can have cast or camber and toe set just right on the vehicle and think that we're in perfect alignment, but if the frame's twisted like this, it's still not going to drive right. It's not going to corner right. It's going to wear tires because our toe out on turns is different. So we start with the frame. Now, I wanted to show you this one. This one has an actual frame. Come over here and look at this car. Okay, now this car has a subframe, it's called, and actually the body is part of the frame. So all the way up to here, okay, this is part of the frame. And some of these cars actually even use the windshield itself as part of the strength for the frame of the car. So if the windshield's broken, the body can twist. It's true. So on this one, we have the subframe that comes here, and then right up underneath here, we have the cradle. Now, if you look at this, this cradle basically is a bolt-on extension of the frame. Does that make sense? Can you see it? Okay. If someone has worked on this, let's say we take the engine out, we're going to take these bolts loose and drop this whole thing out and work on it. When we get done, we bolt it back in. Well, most of these holes right in here where they go through are elongated or oversized like this. We put the cradle in. If we're not careful, we can twist it a little bit like that. Well, if it's twisted, that means that the frame is straight to here, but from here on out where it's bolted in, it's twisted like this. Isn't that going to affect our alignment?
Yes.
Okay, it's the same as a bent frame, only we put it in crooked. So occasionally you're going to get an alignment problem or a steering problem where someone has worked on this engine and bolted this cradle up a little bit crooked. If that's the case, you're going to have to loosen the 4 corner points, take a big pry bar and wiggle it back and forth and get it as straight as you can. Get this out of the way. Now, one of the things that we're going to look at when we do alignment is for shift on this cradle. I want you to picture the top part of these struts go up into the body. The bottom part's hooked down here on this cradle that will move. If we bolt the cradle up and we get it shifted to one side, what are the tires going to do? They're going to go like this, right? When it shifts. So this is going to have positive camber, this is going to have negative camber. So when you're looking at your alignment and seeing if you have a problem, compare side to side. And just remember, if it shifts, it's going to do like this or like this. And if it shifts this way, okay, one of these is going to go back and the other one forward. So it will affect caster on one side. So you compare your caster angles and your camber angles, and that'll tell you if this is shifted. Does that make sense? Yes. All right. So we start with the frame. Once we know the frame is good, then we're ready to move back to more of the suspension components. We're going to go back over here to this one. Okay, this one is a leaf spring. On the leaf spring, we bolt the front of this. This is called the spring eye. And we bolt it here and come back, and we have the ability for it to pivot right here. We have to have something on there for it to pivot. If not, when we hit a bump, this goes up and these springs go straighter, they're going to get longer, right? So we have to have the ability for these springs to change length. These are called a shackle. And one of the things we look for when we're working on a customer's car is to make sure that they haven't been changed. Okay, when I was a teenager, we used to take little pieces of steel and we would make them about this long so that it would stand up taller, and we thought we were really cool. But when you go around corners, the whole thing would sway back and forth, and they were very unstable on the road. But we didn't care because it looked cool. There's still going to be people like me out there that you have to work on their vehicle.
So with the lift kit and you have leaf springs, that's what you do with the back end. You elongate.
One of the things, a lift kit, there's several different kinds of lift kits, but if a customer puts a lift kit on, you need to make sure that it's a certified kit, that it meets specifications, because if it doesn't, somebody just cobbled something together to make it taller, like I did when I was a teenager, and now it's unsafe to drive, and you look at it and tell me the inspection is good, you give it a safety sticker, you tell it it's okay to drive, and it's not, because it's not a good thing, you could be liable. So make sure that things are done to specifications. Otherwise, I would back away from it. Too much liability. Okay, so we have this kind of a system here. You need to look at the springs, because you'll have anywhere from 3 to even 6 or 7 on these to hold the weight of the vehicle. And since these are different lengths, there's a pin that goes right up through the middle, right here, that bolts all 3 of them together. And occasionally this pin will break. And if it does, then these springs can slide back and forth a little bit because they're no longer being held together. When it does that, if this bolt breaks and it slides a little bit, what's the axle going to do?
Slide with it.
It's going to slide back, and now instead of the axle being centered in the vehicle, it's turned sideways and it's pulling off to one side or the other, depending on how it shifts. And so when we're looking at suspension problems, if we have one that's called dog tracking, in other words, the vehicle's going crooked down the road like this, it could be because this axle has shifted and the driver doesn't even realize that's happened. They can't tell the car's going crooked And if the rear end shifts, the vehicle drives sideways and you automatically turn the steering wheel like this to try to make the vehicle go straight. So one key I want you to remember, anytime we climb in a vehicle for suspension or alignment concern, is if the steering wheel is crooked, it's either something has been bent or something is shifted like this. I guess there's a possibility another guy aligned it or did something incorrectly, but most of the time it's a compensation for the driver on the vehicle to try and make it go straight. If it's going crooked, we're automatically going to turn it straight. So if the steering wheel is off, you better look for a reason why. Is that logical? You guys okay with that?
Yeah. Dog tracking is only on the back set of wheels. If it's because with the front set, you turn the wheel anyway.
Yeah,
so
dog tracking is generally caused from the back. Yes. And the rear wheels set the thrust line. We want the thrust line, or how the rear wheels push or turn the vehicle, to be along what's called the geometric center line, or the center line of the vehicle, and the way the wheels push it should be the same. If the wheels are pushing off to one side from the center, that's when we get a dog track. Okay, and we'll check that on the machine. The next style of system we have, after we go to leaf springs, we're back over here. Okay, on these systems, this is a front wheel drive. We have to have some kind of a bar to keep this from moving forward or backwards like this, and to keep it straight. We go from the frame of the vehicle and then how the wheels drop down. We want these to be in the center line of the vehicle. Since these are independent, if we're backing up and we hit a big rock right here with this arm and bend it, that's going to change the length, right?
Got a big old leaf spring.
If we bend it, then it's going to twist like this. So these arms control our toe. They also control the camber, the way the vehicle sets. We're still back with the frame. We've got pivot points on here that can wear. We've got bushings that can wear. We've got arms that can be bent.
That large leaf spring, does that help?
What's that?
That large leaf spring going all the way across?
Yeah, this is called the
Mono spring?
mono spring. See, it's one spring in the middle.
I was wondering where they were.
Yeah, right here. It's not up there like most of them are.
Huh.
So would most cars with independent drive whatever system have this?
No, this is just on a few model vehicles, this type of spring. Now, to set these, you can buy an aftermarket kit, which will replace these, and it'll have adjusting screws so we can move this back and forward a little bit if we need to. We can buy these that have a turnbuckle. I'll show you one here in just a minute to move these back and forth. This one does not have them. Some of them will have an eccentric here, some of them will have an eccentric here, to give us the ability to set our camber and toe. All right? And we're past the frame of the vehicle. We checked that's all good. Now we're starting to check the things that are bolted onto the frame. So we're checking the rear. We got several different styles. This one has a strut, which bolts up here at the top and down here at the bottom. And the angle of that strut sets our caster. Okay? All right, I want to show you one of these that's adjustable, and then we're going to move back up the front. So come over here. Okay, you guys see these arms here? It has a turnbuckle in the middle with a lock nut on each side. If I loosen these lock nuts, a lot easier said than done.
Yeah.
Remember the one we did yesterday? Man, we fought that thing. Poor old Jared only weighs 120 pounds. He didn't have enough weight to turn that turnbuckle.
Josh? Yeah, Josh.
Josh,
That's
yeah.
Josh.
Sorry, Josh. Okay. So we can loosen these. We turn the turnbuckle. It's got a left-hand thread on one side, the right hand on the other. So when we turn it one way, it pulls them both in. Turn it the other way, it pushes them both out. And that's how we set tow on this one. There are others like the one we just looked at. To set tow, you actually have to unbolt the hub and bearing assembly and put a shim in, which is going to be tapered. And if we put the shim in the front or the back, it's going, when we bolt it back up, it's going to move the tire in or out. We can adjust camber and tow with those, and we've done some of those in this class, right? Any questions on those? Everybody's seen it, right? Okay. Aftermarket, you can buy some of these. Now, if we needed to on these arms are both basically identical. If I wanted to, and we were trying to make this more of a performance application, I could buy one of these and put over here. And then I could turn them both, which is going to change my camber. Agreed?
Yep.
So there's a lot of different things we can do to fix these. Some of them are going to have an eccentric here that turns to move the whole thing in and out. Some of them might have an eccentric here. This one turns here. So there's a lot of kits that we can get. We're not going to go over all of the different adjustments. We did that in alignment. This is just a review. Okay, so we have the back here, and we've got to check. We make sure everything's okay, nothing's bent. One thing we have to look for, I want to show you on this vehicle, part of the reason I brought you back here. If this vehicle is picked up, did you just erase my machine that I spent 30 minutes getting on there for?
Yeah, sorry.
Oh.
I'll see if I can find it.
Oh. Okay. On this arm right here, look, this one is straight. On this one here, someone has picked the car up on the arm and it's bent. Can you see it?
Yeah. Oh yeah.
You can physically see the bend. Is that going to affect, do you suppose, maybe caster?
Yeah.
On one side? Yeah, it is.
Going to do a positive caster because of the way it's bent.
Okay, it can affect caster, and when it pulls this way, if something back here, if it bends too far, something's going to have to give back here because it's trying to pivot on these 2 points, and we pulled it closer. So you got to be careful. And when something is bent like this on suspension parts, you do not straighten it. You put a new one on. Okay? I don't want you to try and straighten it. You fix it right. And since it's been bent here, you need to come up here and look at where it's bolted on and make sure that we don't have anything bent back up in here. Okay? I don't know if you guys noticed that when you start, but that's part of your pre-inspection. Did you see
that
this,
bent
Todd?
rod?
Yeah.
Your body audit.
Okay.
What's that going to cause? Did you guys decide already?
Caster.
It's going to affect caster because you're going to pull it in, right?
It's actually going to it's going to affect toe too, right?
Toe.
Yeah.
It's
It
gonna
can
pull it
affect
in.
toe because the whole thing's going to kind of pivot like this. Okay. You guys all right with checking the back? Yep. All right, let's go to the front. We're going to come up. Okay, things that are affecting or can affect the front. The top part of this on this vehicle is bolted to the body. The bottom part is bolted to this cradle. Remember, that's an extension of the frame, and somebody can put it back on crooked. And so, since our pivot point changes from something that's adjustable to a solid part of the car, we need to check our angles very carefully on this. When we check the pivot points, the bottom ball joint and the top of the strut, that is called, you guys remember what it's called?
SAI.
Steering
Axis
Steering
inclination.
axis inclination. That's the pivot points of the car. And it should be solid up there on top, and this ball joint should be solid on the bottom. Agree? If this ball joint is worn real bad and moves all around, then that can allow that ball joint to move over, which is going to change the pivot point, correct? And we're going to read that on SAI on our alignment angles. Remember, steering axis inclination is the pivot points, and they should be solid, and if they are incorrect, that tells us we have a problem. I want you to look. Did we get back to the
Yeah,
screen?
we got the screen back.
Come over here. Look at this one. This is an alignment that we just did and checked yesterday. We noticed a problem before we even pulled it in, but we wanted to verify before it was fixed. I want you to look.
Mark's in front of me.
Steering axis inclination is the pivot points, correct? This one is 19 degrees, this one's 25.4.
Good Lord.
That's a big difference in the way it pivots. The pivot points. Something is bent or something has moved. Would you agree?
Yeah.
Okay, now this isn't cast or camber. This is the solid parts of the vehicle. It's almost like part of the frame. Those pivot points should not move. If they have moved, something has caused it to move. So we're way off here. Now the chart that I gave you is going to give you some general specifications. This is higher than we expect it to be, so I would look for a ball joint, something like that.
Something up high.
And since the number is high, we're going to look high. Agree? You remember that from when we went over it. When we looked at this one, we have an upper ball joint that's worn and moving back and forth about 1/8 of an inch.
And if that
Okay?
number
And
is,
if it moves back and forth, that pivot point has moved. Isn't that going to change our number?
Yep.
Yes. Over here, we have both upper and lower ball joints that are bad. And so one of them shifted like this. The weight of the vehicle is sitting here. The tire's right here. So it's going to take the play on this ball joint this way and the play on this one this way, and the whole tire's going to go like this, because it takes a play out of two ball joints. Does that make sense? Yes. And so when it does, and it pivots like this, it gives us a real high number. Now, we should check these before we even get in here. I just want you to see, if you get work in an alignment shop, we're not just doing caster, camber, and toe. We're checking other parts of the vehicle. This tells us we have a problem. Now, the next part we're going to go to just real briefly is if we take this number, the pivot points, or steering axis inclination, plus or minus camber. Now, camber is how the tire stands up straight, right? You're going to take the pivot points plus or minus how the tire stands up, and it's called included angle because we take the pivot points and include camber. So 14.3 minus 0.7, or excuse me, 19 minus 0.7 is going to be
18.3.
18.3. 25.4 minus 0.8.
24.6.
Okay, and there's our included angle. You see, we calculated ourselves. We don't need the machine to tell us. I want you to understand, we're taking the pivot points plus or minus how the tire stands up. When we include those two together, that's called included angle. And sometimes it'll look like we have a problem with the pivot points, but when we put camber and add that to it, it'll tell us that the pivot points are okay. It's just the tire's not standing upright. In this case, it's telling us we still have a problem, right? We don't want to see our pivot points or steering axis inclination more than 1 degree different. Personally, I like to see them about 1/2 degree. Generally, if you look in your specs, they'll tell you around 1 degree.
1 degree different from each other?
From side to side.
Okay.
Yeah, because remember, we're talking about the solid part of the vehicle, the frame, and the points that are built from the factory to pivot on. And from the factory, they have a tolerance, you know, because they're not all exactly the same. The metal doesn't shrink the same when it's welded. They're not all exactly the same. So they have to have a tolerance built in. Basically, what I want you to understand and remember is the factory's going to take the solid parts of the vehicle and build it. When they get done, if we are the engineers, we know that they're not going to be exactly the same because this metal shrinks more than the last car did. Okay? They're not all exactly the same. So we have to give the technicians the ability to fine-tune the frame and the metal parts of the car. That's called alignment. Well, there's no reason to fine tune something if the main frame is bent. That's why we started with the frame. Okay, so we've gone over SAI and included angle. Now, we're going to come back here and look at our alignment angles. We're not going to review the whole suspension because you guys took those apart in class, right? We've had a short, long arm system apart. We've taken the springs out. We've done torsion bars. We've done struts. Yeah, twin I-beam. You guys have taken all those apart. So I'm not going to show you all that. We're going to go here. Okay, when we're doing alignment, the first thing on the screen is camber. What does camber tell us?
How the tires sitting in.
How the tires lean in or out as viewed from the front, right? And if we're standing outside the car and the top of the tire is leaning towards us, that's positive.
Yep.
Remember I told you if there's a $100 bill on the top of that tire, anytime it comes to you, that's positive.
Yep.
When it goes away, that's negative.
Yep.
Okay. So we have -7 and -8. Camber is going to pull to the most positive. Okay. These are both negative numbers, but which one is the most positive?
-107.
Okay, this one is more positive than this one, even if they're both negative. All right. Now we're going to go to caster.
So according to camber on this one, it's going to pull left.
Yeah, but not very much. We've
Not
only
very
got
much.
1/10 of 1 degree.
Right.
Which is
Okay, and we've got a full circle is 360 degrees, and we take 1 degree out of those 360, and it's only 1/10 of one of those. So it's not very much, but it will pull a little more to this side. Okay, caster tells us what?
how the struts are sitting, pretty much.
How far forward or back the tires are sitting.
Okay, we're looking at the pivot points
Pivot.
and whether they're tilted forward or backward, as viewed from the side. So if we're looking at this car, we're looking at the right side, and if the pivot points are like this, that's positive caster when we're looking at the right front of this car. Straight up would be 0, and if it's leaned back, that's negative caster.
If it's leaning away from the cabin, negative. If it's leaning towards the cabin, it's positive. Isn't it?
That's correct. When we're sitting in the driver's seat, if that $100 bill's on top and it's coming to us, that's positive. Anytime the money's going away from us, that's negative.
Uh-huh.
Okay?
I got it.
And that's on,
Good way to remember.
that's on top of the strut.
Yes.
Yep.
Or the top ball joint, or whatever that pivot point is.
The top pivot point.
Okay, now caster gives us stability when we're driving down the road. In the early systems, when we had no power steering, we had right at 0 degree caster, or very little positive. Some of them even had negative caster, so they would steer easier, because we didn't have power steering. When we went to power steering, we went more positive caster. Okay, when we turn a vehicle that has too much positive caster, one side goes down, the other one picks up in the air. You guys remember seeing that? We did that on Jeff's Bronco. Okay, can you imagine turning the steering wheel and have to pick up the front end of a 3,000 pounds on that car, just manually by hand? If you don't have power steering, they're real hard to turn. If you have too much positive caster, it'll start to vibrate and it'll make it unstable. So we need to check our
You get that?
I think I got that.
Yes.
Okay, we've already talked about this, and toe is what?
Toe is how
How you just
the
behind
angle,
it, dude.
whether the tire's pointing in or out from the
Okay,
front.
that's whether the tires are both pointing straight ahead.
I was just trying
Now,
to-
let me ask you a question, kind of a trick question. If I have toe out on one side and it's straight on the other side, will it cause a pull?
No,
I got a yes and a no. What do
they
you think?
equalize.
They automatically equalize.
Oh.
If one of them's pulling harder than the other one, then it's going to try and pull the steering wheel until they pull around and the pull is even on both sides.
Oh.
And so it may turn your steering wheel a little bit, but it won't cause a pull. Toe is the major, or probably the biggest tire wearing problem on a vehicle. Now, when we set toe on a rear wheel drive, we usually set the toe to be positive or toe in. So it's a little closer at the front than the back. You guys remember why? You got the tire that resists rolling and it pushes down.
Come out of it.
It resists rolling, and so it's going to try and pull back as the car moves forward because it doesn't want to roll. So any play that's in that steering, when the tire pulls back, that play is going to be taken out. And so the manufacturers calculate, we're going to have this much play in the tie rod end, this much in the inner tie rod end, this much here, we may have this much movement in the ball joints. They come up with those things and say, okay, if we set the toe sitting still to be 1/16 of an inch, say, when we're driving down the road and we put that load and take all that play out, it's going to be almost exactly straight. That's how they come up with the toe-in specifications. And it's not going to be the same on all the vehicles because one might have more play than the other one, so it needs more toe-in. You guys okay with that? If I have a front-wheel drive, that changes the whole steering on the front. Because now instead of the tires dragging behind, they're pulling the vehicle. And when they pull the vehicle and drag the rest of it behind, it's going to do exactly the opposite. So we're going to set those with a little bit toe out. So when we pull the car, the play comes out the other way and they go straight. So you need to remember front wheel drive versus rear wheel drive, and make sure you look at the specs and set them accordingly. Does that make sense? The difference between rear and front wheel drive? Why one's toe in, the other's toe out? Okay. Now, when we're looking at these, we can go in and tell it we want to make additional measurements. If we make additional measurements, then it's going to take pictures basically of the car, and it's going to calculate the distance between the center of the rear wheel and the center of the front wheel on one side, and it'll tell you how far apart they are, and then it'll do the other side. Okay, and that's basically checking the wheelbase. Then it's going to look and see, are these here straight in line with these in front, and it'll tell you if it's setting off to one side on front or back. So if we have one that's run into a curb, basically, in my opinion, anything that is hit hard enough to bend a rim or pop a tire has a possibility of bending suspension components. So if they come in and all they did was run into a curb and popped a tire and they want you to check the alignment, as far as I'm concerned, as your instructor, that means that you go past caster, camber, and toe, because if they are hard enough to bend a rim, bend the arm like the one we just looked at, yeah, can it move the cradle? Yeah. Can it bend the tie rod? Uh-huh. So we need to look at those things and make sure that we don't have a problem. Another thing that we've seen a lot, wintertime we have snow. We got a parking lot with 2 inches of snow and it's empty and nobody's there. When you come in the morning, remember seeing all those donuts there?
Yeah.
Okay, I know nobody in this class did it, but somebody pulled donuts.
That was yours.
If you're out there spinning around having fun and you get too close and all of a sudden you hit a curb and bounce off,
You gotta go the other way.
possibility it can bend that rim or shift the whole rear end over a little bit or bend alignment. It depends on whether it's solid axle. It doesn't matter what we've got, but we're going to bend that. You guys all right with that? Mm-hmm. You can see that happening. Another scenario, I'm sitting at a stop sign and somebody turns the corner and misses the corner and hits the front of my car. Their bumper's going to hit right near the top of the tire. Agreed?
Yes.
And I take it in and they put a new fender on it and straighten it. When we get done, there's a possibility that upper arm or the upper pivot point for the McPherson strut could have been bent in. How are we going to find that? If they put a new fender on it, they paint it, and everything looks good. How do we find it?
Yes, sir.
Wheelbase.
Pivot points. SAI.
Oh, yeah.
Okay? We're going to compare and move. Now, what I want you to visualize, if the top of a strut, let's say we have a strut, and this is the top, and it's part of the body, and I'm hit right here, there's a possibility it bends in like this, right? Well, this between the upper and lower pivot point is called steering axis inclination, the pivot points. If the